right. Well, good morning, good afternoon, good evening, everyone, and welcome to the world's most exciting classroom. My name is Joe Grabowski, and I'll be your host for today. We have lots to catch up on. We have some really cool new content today, a live guest speaker. We're going to hang out with elephant seals on the beach later from an earlier session. But the first thing that we're going to need to do is we're going to catch up on where the Oosterschedle and the DARWIN200 team are in the world. So let me share my screen really quickly here. You should see the map coming up shortly. There it is. All right, let's make it a little bit bigger. So here we are in the world. I can't believe how close we are to wrapping up this epic 2-year journey following Darwin's voyage of the Beagle. We left up here. You can see, oh, I need to move my cursor a little bit. Let's get it. No, it's not showing up on the screen. All right, that's okay. But you can see where we end up here in the UK. We started in Plymouth back in August 2023. We've sailed around the planet. Recently, we were in Cape Town, St. Helena, Ascension, and we are now making our way towards the Azores. If I zoom in a little bit closer here, you can see we passed Cape Verde not too long ago, not stopping this time on the way out. Almost 2 years ago, we did stop in Cape Verde, and you can see the Azores are not that far away. Our last stop on the journey. Oh, there's my mouse. It's showing up now. That's good. And then, yeah, around July 18th, July 19th, we will return to Falmouth, and the 2-year journey will come to an end. We still have several more world's most exciting classroom events before that happens. You'll notice there hasn't been any new pictures loaded to our trail, pictures or videos, since just before we got to St. Helena. As you probably know, both Starlink units, after 2 years of, I guess, us abusing them as we've sailed all around the world, we have lost our Starlink units. Both of them aren't working, but we will get new ones, hopefully around the Azores. And so we'll have some connections, more live connections from the ship before that wraps up. So coming back from that screen share, let's get into our guest speaker action for today. Really, really excited to have Sara Kross joining us today. Sara is a conservation biologist interested in human-modified landscapes, ecosystem services, human-wildlife conflicts, predator-prey dynamics, and ecotoxicology. Her work has largely focused on the interactions between birds and people in cities and on farms, but she's also worked with mammals and vertebrates, and is also really interested in understanding people's perceptions of wildlife. She's a senior lecturer in terrestrial ecology at the University of Canterbury in Christchurch, New Zealand. Let's grab Sara in from backstage right now. Here we go. Hey, Sara, how you doing?
Kia ora, everyone. I'm great. How are you?
Good, good. It's so great to have you joining us live today with these events that we've been doing, connecting with classrooms in Australia and New Zealand. We've featured so many cool researchers and explorers and conservationists from Australia and New Zealand. But it's been a while since we've kind of slipped back into New Zealand. So it's so great to have you with us.
Thanks, Joe. I'm really happy to be representing this amazing part of the world.
All right, perfect. Well, I'm going to let you take over for a little bit. Students will be putting questions into the chat, and we'll tackle some of those shortly. But for now, let's get into some of the things you like to explore and research.
Thank you. Great. So, kia ora, everyone. Again, really excited to be here. My name is Sara Kross. I am here in Ōtautahi, Christchurch, which is in Aotearoa, New Zealand. My contact details are there if you want to follow up at all after this, but I'm going to talk about some of my research today, particularly in birds of prey in farmland. I thought before I started, I would just give you a little bit of my natural history, my background. You'll probably note that I don't have a New Zealand accent. I'm actually originally born and raised in New York City. I did a semester abroad here in New Zealand and went to this event where we dressed up as Ninja Turtles, but I've been here in Aotearoa, New Zealand off and on for about 20 years. I lived on the west coast of Canada for a year. I did my master's degree at the University of St. Andrews in Scotland. I came back to New Zealand to do my PhD, which is what a lot of my presentation today will be about. And then went to California to work in California Central Valley to study birds and barn owls and other wildlife in that system. I then returned to my hometown of New York City, where I worked at Columbia University for about 4 years and did quite a bit on urban wildlife there. And I've been fortunate enough to come back to Canterbury, where I did my PhD, to now be establishing here as a researcher. So I've been around the world, not quite the same journey that your ship has been on, but I think as a scientist, one of the really cool things about our lives is that we do end up moving a bit and exploring different places and learning about the systems in those areas. I'm really motivated by the idea that we all have a part to play when it comes to conservation biology. Conservation is really critical in all of those beautiful, pristine landscapes that I'm sure many of your field trips have been to, but it's also very, very important that we do a good job in our backyards, and that the people who are lucky enough to be stewards of land or to be able to volunteer on land or manage land are playing a very important role in the well-being of our planet and wildlife in particular. I focus a lot of my work, as Joe said, in highly modified landscapes. And one of those is the agricultural landscape. So if you added up all of the land that's used on the planet for growing our food, our fuel, and our fibers, which are considered our agricultural ecosystems, they actually add up to be the largest terrestrial biome on the planet. There's more of that there than there is any other type of land. And so this is what we often look at as being kind of more desert-like in the sense of the word, that there's, we often look at these landscapes as not having the pristine values that we are excited about in conservation biology a lot of the time. But I also see these as landscapes where there is a lot of ability to do good and to make inroads that will bring them back toward being host to more native species. I focus mainly on birds. And the expansion of the footprint of agriculture and the intensification of how we do farming in the modern world has been called the greatest extinction threat to birds. And that is true of many different taxa of wildlife around the planet. And the story I'm going to tell you today and what I'm going to talk to you about is a bit about the combination of two different kind of fields that often don't go hand in hand. So when we think about things like the conservation of apex predators and reintroduction projects or rewilding projects where we're bringing wildlife back into, particularly those predators, back into systems, when we think about vertebrates like wolves and birds of prey, most of the landscapes that we picture and that are really the focus of a lot of these projects are those wilder natural landscapes. And on the other side of the equation are those landscapes that I was talking about that are used for growing our food, fuel, and fiber. And so these are two things that are, weren't really talked about hand in hand. They were often seen as being kind of two very different fields of conservation. And the project that I'm going to talk to you about really mushes them together. So I, for my PhD, studied the kare area, which is the New Zealand falcon. It's an endemic bird of prey that is found in New Zealand. It's the only endemic bird of prey. And endemic species, if you haven't heard about them in your classes before, are species that are found only in one place and nowhere else on the planet. So this is a bird that is found only in New Zealand, and it is not found anywhere outside of New Zealand naturally. And that is true of many of the species in New Zealand. New Zealand is a very unique environment, just like the Galapagos, when it comes to the endemic species that are present here and how different they can be from similar species elsewhere in the world because of the long period of evolutionary history in which they've been separated from other land masses. And I want to tell you a story about this species in a region of Aotearoa called Marlborough. This is the top of the South Island of New Zealand. The little square there is showing you roughly where it is. And this is an area that if you went and stood there, actually very much on a day like today, where it's winter here in New Zealand, or the very end of fall, you would see it looking similar to what this photograph looks like. So there are two wide river valleys in the region, and those are entirely covered in wine grape vineyards. It's a pretty intensively farmed landscape. There's very few trees. There's very little natural habitat in the flat areas. And then behind the vines, what you can see are the pretty typical kind of low intensity rangeland, pastoral type farming that's very typical in New Zealand's hilly countries, which is usually sheep farming. There's a bit of forestry you can see there, and then you can see more of the alpine environment in the background, which is generally not farmed and is more used, or it's generally part of what we call the conservation estate. And in Marlborough, one of the really big challenges that grape growers face is that this system is so altered. New Zealand really has a bad track record when it comes to the conservation of many of its systems. And these river valleys are covered in grapes, and then most of the species that you find in them are actually introduced species that were brought here intentionally or unintentionally and have now become pests. And so in Marlborough, because they grow up these really delicious grapes, they have a big problem when it comes to bird pests, which are largely introduced species, actually eating those grapes and eating millions and millions and millions of dollars worth of grapes every single year. And so grape growers there are often trying to chase the birds away and kind of get rid of them. So this is my guy again. This is the New Zealand falcon. Their Latin name is Falco novaezelandiae, which is a pretty easy one to remember. They're pretty small. If any of you are familiar with falcons elsewhere in the world, they're bigger than like a kestrel, but smaller than a peregrine falcon. But they're world renowned for being really fierce predators and being able to take down quite large prey like a hare. Before Europeans came to New Zealand, they were found right from the tops of those mountains down to the sea. But today they are generally restricted to what's called the high country. So those hilly areas that I was showing you that were above the vines. When I did my research, the species was classified as nationally threatened. It's a few years on now, and they've been reassessed, and they're considered at risk recovering in the New Zealand system. So they're not a critically endangered species, but they're not doing particularly well. And a large reason for that is that they are ground nesting species, which is an odd trait to have if you are the fastest, most agile flying species in New Zealand, one of the apex predators of this land. But in the context of the evolution of New Zealand, we actually have a lot of species that are either flightless, like the kakapo and the kiwi, which are really famous for kind of those quirky traits, and many species that even being flighted will nest on the ground, because throughout evolutionary history, the only predators that they had were flighted birds, like the Haast eagle, which was one of the largest birds of prey that ever existed on the planet. They had claws the size of lions' claws. So if your main predators were also birds that could fly, putting your nest on the ground in a place that's actually pretty well protected from attacks from above was a pretty good strategy for trying to keep your nest from being attacked. Unfortunately, people brought with them, when they first colonized New Zealand, when Maori first came here, they brought the Kiore rat, and then later when Europeans colonized New Zealand, they brought a number of different introduced mammalian species. And those species hunt with, first of all, they're on the ground. And then there are species that hunt with their sense of smell, and they hunt at night, which is very different than what most of the natural predators in New Zealand used in terms of hunting strategies. And so those predators are very, very dangerous to these 3 eggs that you can see in this nest here, which was on the side of a hill in kind of a little depression underneath a fallen punga tree, which is the tree ferns that New Zealand is famous for. In addition to ground nesting, like predators are the main risk for this species. There's also a history of persecution where people have actively tried to kill falcons to try to discourage them from doing things like attacking their pet doves or chickens, which doesn't happen that often, but it can sometimes happen. And we've discovered that they're actually prone to being electrocuted by power lines. So that's another thing that another side to the conservation story we're trying to work against. So the project I studied was called Falcons for Grapes. And it was run by a company called International Wildlife Consultants based out of the UK. And what they did is they were translocating falcon chicks from the high country, from those areas in the hills that I showed you in the photo above the vines, and into the vineyards of Marlborough. And so they were doing this, as the name implies, to try to reintroduce a predator into a system that essentially had no predators present in it. And they thought that that would create behavioral changes in the birds that were eating the grapes like they were at an all-you-can-eat buffet, and make them be a bit more nervous and maybe not spend as much time out in the vineyards, spend more time in the trees and things, and therefore create less damage for the vines. And the kind of important thing that had to go along with that potential for ecosystem services was that the falcons had to benefit in some way. So what I was doing was trying to understand, was this a good idea? Did this work well as a reintroduction project for actually reducing the amount of damage to the vines? And was it a good idea from the perspective of this threatened species to be reintroducing them from these low intensity kind of pastoral grazing and bush type habitats into this very intensive agricultural landscape, which historically we haven't really thought is a good match for conservation? So this was my kind of formal question. All of this work has been published now. If you want papers or you want to read more about the details of any of this, feel free to let me know and I can send it through via Joe. So from the, does this help the vineyard side of things, we were interested in a few key culprits. There were 3 species of introduced birds, the starling, the blackbird, and the song thrush, which are all from Europe. Those birds all like to eat grapes like we would. So they'll pluck whole grapes off of the bunch, they'll swallow them down, then they'll go get more. And so you get left with, I'm not sure if you guys can see my mouse, probably not, but you get left with what looks like if you or I went and pulled grapes off of bunches. You get that little bit of skin that sometimes is left, and that little kind of bit where the grape connects is called the pedicel, and you can often see that poking out. And this is a bunch of grapes that every single grape has been taken off of this bunch by birds. The other culprit is the silveri, or the toho. This is a self-introduced native species. So it's naturally found here in New Zealand. It wasn't introduced by people, but it only became common in New Zealand after the wide-scale habitat alterations that were created by Europeans when they cleared a lot of land and started farming it. And so the Māori name, the Te Reo name here, actually means stranger, because this is a bird that wasn't very abundant until after kind of very modern changes in the landscape. Silveris are little birds. They are only about that big. They are omnivores, but in the fall, they really love the juice from inside these grapes. And so they'll go in and they'll peck holes in the grapes. And you can see this bunch of grapes has got lots of holes pecked in the different grapes. They'll drink some of the juice from inside the grape. Then they'll be like, I'll try that one over there. They'll peck another hole in it. You can see quite a few of those have been pecked, and some of them were pecked a while ago, and some of them look like they're more recently pecked. But the problem here is not only that those grapes might be lost in terms of being able to process them into the final product, but also that the juice from those wounds will kind of weep all over the bunch, and it can cause the whole bunch of grapes to rot. So they can both cause problems. And cutting to what we found, I went out for 17 weeks straight and went to quite a few different vineyards that either had falcons present in them or did not have falcons present in them. And I went out really early in the morning and I counted how many birds of any species I saw, but focusing on these 4 kind of more dangerous species for the vineyards. What we found was that falcons had a significant effect on the song thrushes and the blackbirds. There were about 80% fewer of them. There were about 80% fewer starlings, and that was statistically kind of marginally significant. But if you look at the graph here, you can see that the dotted line, which is the line when there was no falcon present, can have flocks of 20 to 40 birds present, whereas in the vineyards that had falcons present, this kind of gray solid line, there were often between 0 and 5 starlings present. So the numbers could go up and down in the other vineyards, but they stayed pretty low in the falcon vineyards. And then we actually found there was no effect of falcon presence on silveris. So there were kind of similar numbers of silveris when there were falcons present and when there weren't. When we went out and then counted the amount of damage to grapes in the vineyards that did have falcons and did not. So in this case, both of these graphs, the graph on the top is showing you for a white wine variety called Sauvignon Blanc, and the graph on the bottom is showing for a red wine variety called Pinot Noir. What we found was that when there was a falcon present in the vineyards, across the board, there was about a 68 to 69% decline in how much damage there was to the grapes. So there was a really significant increase in the yield that those growers had. And we found this was largely because those European birds were taking 95% fewer grapes. So they were really reducing how much they were foraging in those vineyards. But there was also half as much pecking damage from the silver eyes. So even though the falcons didn't scare the silver eyes away completely, the silver eyes were foraging less efficiently and were actually damaging less of the crop there. So really good story from the vineyards perspective. And to be honest, when we published this work, like vineyards were calling me on the phone saying, how do I get a falcon in my vineyard? I want one. Like, they're wild birds, so it's not like something we could just do. But it was a really big shift in the way that grape growers were seeing these native, endemic, really treasured species as potentially being important parts of their farming system. Then thinking about whether or not this is good for falcons, it's a little bit of a harder one to do, but what I looked at was studying the behavior of falcons. So looking at things like how often they were in their nest, what kind of food they were bringing back to their chicks. These are two falcons kind of switching off. This is what the chicks look like. They're quite ugly. That's a prey item. That's a rabbit. There's another prey item. And then I had this footage of a cat, a feral cat actually attacking and killing two of the chicks in one of my nests, which I won't show you here. But that's the beginning of that footage. And it was really, really upsetting to see. But it was evidence that this one of these dangerous introduced predators that are unfortunately pretty common around New Zealand will even go and attack the kind of most fierce predator that we have, which is still a relatively small bird compared to something like a feral cat. What we found is generally that living in the vineyards wasn't a bad life for the falcons. So when we looked at how much time the different parents actually spent in the nest, I call that nest attendance, in the 30 days from when the chicks hatched to when they fledged from the nest, we found that the falcons in the vineyards, the females, the mothers, spent a bit more time with their chicks, which we can interpret to mean that they weren't as stressed for food and they were actually being able to kind of keep up with the food requirements of their chicks without having, too much additional stress on them. So they were able to spend a bit more time at home, essentially. The males in this species do most of the hunting. So the females were able to sit there, brood their chicks, keep them warm more often, and the males were able to bring in more of that food. These falcons were being provided with some supplementary food at the time I was studying them, although most of the nests I monitored, I didn't see any evidence of them bringing in the supplementary food. It was day-old chicks from the poultry industry, so they were really different color than anything else they were eating. But the management itself may have been part of the reason that the falcons were doing pretty well. I used some fake eggs. I made some eggs out of wax to understand whether or not their nests were more likely to be attacked by predators at the egg phase, which is a time when it's really hard to actually find the nests of falcons because they're pretty secretive about them. And I scented them. I put them in with materials that were from real falcon nests. And I left them out. I had to tie them to the ground with wire to make sure nothing would steal them. And I found evidence that the nests in the hills were actually attacked earlier, and more of them were attacked by predators than the nests in the vineyards. And particularly the orange bar in the middle for the graph that is showing you hills, that's talking about or pointing out what are called stoats, which is a type of mustelid. It's like a small ferret. And those are really, really fierce predators, and they will attack eggs. And we only found those attacking the nests in the hills, not in the vineyards. Interestingly, hedgehogs were present in both habitats and were attacking the eggs in both habitats. So hedgehogs are cute, but they are actually a very dangerous predator, especially for eggs. And so ground nests are a big problem. When we looked at the diet of the falcons, because you're putting an apex predator into a system and it's going to hunt for things, right? And when we looked at what the falcons were eating compared to what was available to them in the habitat around their nests, what we found here, and really just pay attention to that black line that goes diagonally through this, anything above that line were species that falcon were eating more often than we would expect them to. And anything below that line were things that falcons were eating less often than we would expect them to. And the orange species here are all introduced species, and the green species are endemic species. And then the silver eye is a native species, so it's kind of in between. But what we see here is that falcon are actually eating introduced birds more often than we would expect them to. And they're eating the endemic species, the ones that we probably don't really want them to be eating lots of right now, less often than we expect them to. And so that's potentially a good sign for the benefit of those apex predators not necessarily interfering with other conservation efforts that are going on. So that's my falcon story. I wanted to just point out that this is one piece of the research that my students and I do. We've also worked on barn owls in California and understanding whether or not they might help to control rodent pests. We've worked on songbirds and looking at whether or not they affect insect pests and whether or not the songbirds themselves cause damage. And we've done that in California and in New York and in New Zealand. And we're doing it more with collaborators in Australia and Europe and other parts of the world. I do work in urban systems, so I have done quite a bit in New York City, and I'm increasingly doing research here in Oosterschedle and Christchurch to understand how habitat that we plant in our backyards and in urban parks plays a role in maintaining and kind of benefiting biodiversity, and then what people get out of that relationship as well. This is some examples of some of the work that we do in New York City to try to understand which species are found in parks across a gradient going from Brooklyn out into Nassau County. We also look at the risks of these landscapes to wildlife. So in urban environments, we're looking at things like collisions with buildings as being a real potential risk to species. In agricultural systems, we're doing quite a bit of ecotoxicology, where we're looking at the potential downsides of living in those environments in terms of things like exposure to pesticides. And so, yeah, we do lots of things. It ranges from pollinators to birds to rats and stoats to insects and bears and all kinds of interesting stuff, in my opinion. And lots of really cool people that are in our lab over the years that have contributed to this work. So, Joe, I don't know how I'm doing for time, but that is kind of what I wanted to share with you.
No, that's perfect, Sarah. Great timing.
Great.
All right. Let me take that presentation backstage. There we go. Sarah, thank you so much. I'm a huge fan of birds. I love seeing birds in the wild. I visited New Zealand. It was years ago, but I just love how New Zealand, originally relatively mammal free, except for a few bat species, and how the birds filled all of those niches. But then you have that story, the invasive mammals coming in and really decimating the populations. But the research you're doing is really exciting. And we've had a couple other researchers join us talking about a few other different species. So whether it's predator-free New Zealand and all the different projects going on right now, conservation is really a focus and really great to see.
Yeah, and what I think one of the coolest things about New Zealand is just how much everyday people are involved in these conservation efforts here. Like the kids in my kids' school are learning about trapping and how to control invasive predators and are involved in restoration plantings and stuff. So I think in a couple of decades, it's going to look very different here, and it's really inspiring.
Yeah, absolutely. So you mentioned that the farmers, after seeing some of the results with the falcons, all wanted their own falcons. Is that a program that might start in the future, or is there still more research to be done?
Because this is a threatened species and they're really not very common at all, it's not so much that anyone can have their own falcon. And I guess that was one of the misconceptions. The Falcon Project has continued. It's continued as a locally run project called the Karearea Falcon Conservation Trust. And they do continue to release falcons in the valley, and the population of falcons has increased in that area. I actually have a PhD student now who's looking at grape damage in the vineyards in Marlborough, and the numbers of grapes that are damaged now seem much lower than they were when I did this work about 10 years ago. And it's probably a combination of there being more falcons around and potentially there being a lot more grapes around so that there's more food to kind of share. But yeah, it does seem like there's the rates of damage are going down. But the work that we started then and continue to do related to education has really put the falcon into the public eye a lot, and people are really excited to see them now and do spot them a lot more.
Okay. Some more questions here are starting to come in via the chat. The cameras in the nest, do those bug the birds at all?
Not that we could see. When I first put them in, they use what's called a no-glow infrared light. So it's a light that the birds shouldn't be able to see at night. They noticed it when we first put them in the nest because they were like, what is that thing over there? And a couple of times, well, in a couple of the nests, I saw like the female falcon come and look at it and get really close and then just go about her business. The cameras are really useful because it means we don't have to sit there for a long time to actually monitor the birds. But I should say, and I should have put the video in here, these birds are fiercely defensive of their nests. And so what bothered them was when I went back once a week to change the batteries and the SD cards, and they are one of the only birds that will actually make contact with you when they dive at you. So they would hammer me. I had a special hat that I wore with padding inside it and padding on top of it so it wouldn't hurt them and they wouldn't hurt me. But they would come at full speed, which is about 60 miles an hour potentially, and whack me in the head over and over and over again until I got out of there. So even though I was promising them I was not there to hurt them, and we did it as quickly as we could and as rarely as we could, we still were getting close to them. So it was more of the researcher being there, and that's why it was good to be able to leave the cameras, leave them alone for a week at a time, and then go back rather than try to sit there to monitor them.
All right. Jasmine wants to know what the biggest falcon you've ever seen is.
Ooh. Oh my goodness, that is a good question. I think the largest falcon is a gyrfalcon, which is found in the Arctic, actually. Mm-hmm. That would probably be the biggest one. The New Zealand falcon is one of the smallest falcons. It's not as big as it's not as small as like a kestrel is. But the males stand about that tall, and the females are about that tall. So they're relatively small. I remember when we first brought them to schools, kids were like, what is that tiny thing? Like they were expecting to see a big eagle. And they were surprised by how fierce these little birds are.
Yeah, absolutely. Okay, let's see. Olivia wants to know about, I mean, you talked about the falcons, but she's wondering if that's your favorite bird or if it's another species.
Oh, that's like asking about a favorite child, Olivia. I think that my favorite bird is probably the Kia. Have you had a Kia person come and talk, Joe, at all?
We did. Your friend who connected us.
I think Jimena did. Yeah, she was actually my supervisor.
Yeah.
The Kia is such a cool bird because it's an alpine parrot. And they're really, really smart and they're really, really cheeky. So they will like go steal things from you when you're out in the bush, and they just appear to like laugh at you and hop around just out of your reach. They can solve problems. They're really smart. And then I think my other kind of favorite bird here in New Zealand is called a piwakawaka, a fantail, because they're little and they're cute and they're friendly. They'll come right up to you and squeak in your face and fly all around you, because what we think they want or what they think they're doing is that they would have once followed the moa around, which were these big ostrich-like birds that lived in the bush. And when those birds walked through the bush, they would kind of disturb all the branches. And so the moths and things would fly out of the bushes. So we think there's quite a few birds in New Zealand that will actually come to you because they're taking advantage of the fact that the big things that once were here would actually have been getting food for them. So piwakawaka are really, really cute.
All right, very cool. Haru wants to know more about the hedgehogs. Why are they going into the falcon's nests?
Partly because the falcon's nests are on the ground, so they're easier pickings. They smell strongly of the birds and what they eat. And hedgehogs, as you know, they look like they're just kind of a roll of cute but spiky things. When you look at their teeth, you'll actually see that they're quite carnivorous. So they do attack and eat animals as a pretty good part of their diet. They can eat other things too, but they really like eggs. They really like eating large insects and things. So there's actually quite a few species in New Zealand that are at risk because of hedgehogs. And because of the fact that a lot of species, the way that they hide from something that they perceive as being a threat is by like getting underneath something or getting low to the ground and staying very still. Because birds of prey, the way they detect their prey is by sensing the movement of their prey. So When a hedgehog or a rat or something is snuffling on the ground, even a falcon will actually stay still on the ground as a way of trying to stay away from that predator. And that just makes them really easy pickings.
Yeah. Okay. Hunter wants to know about the lifespan of these falcons.
Oh, I think some of the falcons that I was studying, the wild ones, only stopped being seen a couple of years ago. So in the wild, most of them are not even making it to a year, as is true of most species. But the ones that do make it through, some of them are living to be 6, 8 years old. And in captivity, it looks like they can live like 10 to 12 years.
Okay. Final question for you, Sarah. Spencer, you mentioned getting swooped by the falcons while you were changing the batteries. Is there any other reason why they might swoop a person?
Only if you were near their nest. During the non-breeding season, or if you're out in the bush or at home, like falcons are curious about people, just like a lot of birds in New Zealand are. They don't recognize us as predators. And so here in New Zealand, they might even like perch on a branch near you and see what you're doing. My kids and I went for a hike a couple weeks ago, and a juvenile falcon like followed us out of the woods and just sat in a tree above us watching us eat our snacks, just out of curiosity more than anything, I think. But no, they're really only aggressive toward their nests or near their nests. And that's because they are trying to, in that situation, whenever anything gets close to their nest, their response is to attack it. So they will attack cars. There is a story about one attacking a helicopter once, which seems really dangerous for the falcon. But yeah, they will swoop at you for sure. And they will hit you with their talons. And I knew quite a few people who were a bit macho about it, and they wouldn't wear any head protection, and you'd get like bloody, like they will attack and scratch you really seriously. So if you're here in New Zealand, please don't go near any falcon nests. It's stressful for them. Unless you have a good reason and a permit to do that, it is not a good idea to go near one, and it's actually against the law. And that's true of falcons everywhere in the world. Birds of prey are protected virtually everywhere, and for all birds, we really shouldn't bother them when they're nesting unless we have a really good reason to do it.
All right. Well, Sarah, thank you so much for sharing some of your research with us. It's a great story. You know, birds are obviously great, but also a story looking at invasive species, but then, you know, how native species can play a role in controlling them as well. So a great story, and good luck with the continued research.
Thank you. Thanks, guys. And thanks for the awesome questions. That was really fun.
All right, Sarah, have a great rest of the day. Thanks so much.
See ya. Bye.
All right. Very cool to have Sarah hang out with us from New Zealand, doing really great work, conservation, research. We love to hear those stories in New Zealand. We've been able to feature a lot of those stories. So really nice to put together a picture of some of the important research and conservation work that's happening. Well, we're going to look at that elephant seal footage that I promised you last week. But before we do, I want to tackle our experiment from 2 weeks ago. If you remember, we had our experiment where we were tricking our brains, where we had the really hot water, the really cold water, and then the room temperature water in the middle. So let's take a look at the results of that experiment, and then we'll get into some elephant seal action after that. So bear with me for just a second while I load up that results video, and here it goes. I'm going to share my screen one more time here just to remind you of our experiment from 2 weeks ago where we tried to fool our brain. We have an experiment for this week, and I picked a really, really easy experiment. Turn the volume down there because we don't need the volume, but we do need to be able to fast forward a little. So that's what I'm going to do. So with this experiment, it was probably the simplest one we've ever done. We had 3 bowls. In one bowl, we had really cold water. In one bowl, we had really hot water. Not so hot you couldn't put your hand in it, of course. And then in the middle bowl, we had room temperature water. Now, what we did is we put a hand in the cold water for 30 seconds, and we put our other hand in the hot water for 30 seconds. Just kept our hands in there. From there, we took both hands out and put them into the room temperature water. And then what did we feel? Well, what we felt was our hand that was in the cold water felt very hot when we put it into the room temperature water. And then our hand that was in the cold water, our hand that was in the warm water felt very cold when we put it in the room temperature water, which is strange. It's a complete reversal of what our hands were just feeling, especially when we put it into water that should have just been kind of room temperature. So not warm, not cold. So what was going on there? How did we trick our brains? Well, we've got thermoreceptors in our hands, well, all over our body, but in particular, we were looking at our hands this time because we had our hands in the cold, our hands in the warm. So we really activated our warm receptors in the warm water and our cold receptors in that cold water. So we really confused our senses when we took our hands out after 30 seconds and we put them right into that room temperature water. So our thermoreceptors aren't thermometers. They don't say, this is 30 degrees Celsius or this is minus 10 degrees Celsius. They kind of measure relative. So, this is cold, this is warm. So when we primed our one hand to be thinking about really warm with the warm receptors and our other hand to be thinking about really cold with the cold receptors, then we put them both into that water. Our warm hand felt relatively cold because it moved into the room temperature water, and our cold hand felt relatively warm because it moved to the room temperature water. And so that's an evolutionary response. It's really valuable for us to be able to feel temperature changes and react to them. For instance, if you're in the kitchen and you're cooking and you accidentally put your hand on a hot pot and you pull your hand away really quickly. So your body doesn't really ask questions about what temperature is this? Can I keep my hand here? You react. Your warm receptors react. So that's an evolutionary thing. We're primed to react to these temperature changes. And so that's what we did with our body. Even though the water in the middle wasn't hot, it wasn't cold, it was just regular old room temperature water, to our hands that were in really cold water and really hot water, it felt extreme. It felt like the really hot hand was suddenly feeling very cold and the really cold hand was suddenly feeling very hot. So that was our experiment where we tricked our bodies with those different water temperatures. And so again, it's relative. It isn't hot water, it isn't cold water. We don't measure in that way, but our bodies are primed to respond to that change in temperature. So it felt much more extreme than it actually was. Okay, so there we go. That was our experiment from 2 weeks ago where we kind of fooled the receptors, the thermoreceptors in our hands. We had our hands in the really warm water, the really cold water. Then when we put in the room temperature water, both hands felt the exact opposite, as if we put our hot hand into really cold and our cold hand into really hot. And it's because our body, that quick switch, gave us a quick warning that, oh no, this temperature has really changed. Even though it's not enough to hurt you, and the water is really just room temperature, for that few moments when you make that change, your body is really, really confused. So if you haven't tried that, try that out in your classroom, try it out at home. It's a really cool experiment. And yeah, it's kind of fun to do. So we are going to go to California now. A few days ago, my friend Roxanne Beltran, she studies elephant seals. She puts cameras on them to look at what they're doing when they go into the water and they're hunting, to try and shed light on their secret lives in the ocean. So she went out to the beach to hang out with some elephant seals for us. So I have a little clip from that I want to share with you right now. It's really cool. So just give me a second here. It will load now.
So there you can see a big group. There's probably about 200 elephant seals in that group, and you'll probably notice some of them are lighter blonde and some of them are darker gray. And I'll talk a little bit about that in a second, but we're actually in the molting season right now. So for those of you who have cats or dogs, they get fur on your clothes, they shed all the time. Seals are the same, but instead of shedding throughout the year, they come onto the beaches and shed their whole fur coat all at once. It peels off. And that happens in the span of about 2 weeks. So that is an adult female. She's about 6 years old. And if you can see on her left side there, she has a number E715. That's E715. So she's a seal that my research team has kept track of ever since she was a pup. So she was born right here at Año Nuevo. She nursed from her mom's milk for about a month, and then her mom abandoned her, went to sea. And this seal, E715, spent a couple weeks on the beach holding her breath, trying to figure out how to do breath hold diving, which is really important for them, and then went off to her first trip to sea. So she swam out, made it past all that low tide beach, and then went out to sea, got past all those big boys who were sleeping in the water, and then went out into the middle of the Northeast Pacific Ocean. She probably did a migration that was around 3,000 miles round trip, and that was to search for fish and squid to eat. So she did that her first year, and her second year, and her third year, and she's come back every single year for the last 6 years to Año Nuevo. Right now, you can see she's probably leaving for her foraging migration. So you can see her coat is nice and silver, and she's kind of skinny. So she's probably been on the beach for about a month, and she replaced her whole fur coat. So when she got to the beach, she looked more like this blonde, one of these two kind of blonde males that you see here. That's an old fur coat. And then she peeled off that fur coat and totally replaced it with beautiful silver new fur. When she's on the beach, she can't find any food, right? There's no fish, there's no squid to eat here. So she basically relies on the fat stores that she has stored in blubber on her body. So she basically doesn't eat for a whole month while she replaces that fur coat, and then she takes off to sea. So she'll probably go into the water right now, and then she'll be spending 7 months out in the Northeast Pacific Ocean, diving down to about 3,000 feet underwater. So if you look up at the ceiling in the room that you're in, you might be in like an 8 or 10 foot ceiling. Imagine 3,000 feet. That's a 30-story building. That's how deep the seal will dive throughout her whole foraging migration for 7 months in order to find enough food. Okay, so there she goes on her great adventure. I'm going to take you guys around to see this little group. We're going to kind of try to keep our distance so we don't disturb them. You see this big male, he just did a big yawn for me. He's probably about 5 years old. And then this little seal that I'm going to show you is about 1 year old. And you can see, based on the color of this seal's coat, that it has also finished molting. So we have that nice silvery coat. So you might be wondering why some of the seals have marks on their side. And the long story short is that we like to keep track of individual animals. Some of our research focuses on how individual seals are really different, and what that means for how successful they are. And so when they're pups, when they're young of the year, about 30 or 40 days old, we give them flipper tags. So hopefully you saw that little bit of green plastic. Those green plastic bits are what we call flipper tags. They're placed in the rear flippers of the seals when the seals are pups, and they stay in for the seals' entire lives. And that basically allows us to collect information about individual seals and really get to know them. Like, how old is that seal? Well, if it was born in 2020 and we're now in 2025, that seal would be 5 years old. For the females, we ask questions like, how many pups have they given birth to? Or when do they come to the beach? Is it early in the season or late in the season? How consistent are they in where they swim at sea or how deep they dive? And so those flipper tags help us because we can, in our database, collect information. Every single day we see the seal for the seal's entire life. But you probably noticed the flipper tags are pretty small. So my team and I read those flipper tags, and once they read the numbers, they basically stamp that number on the side of the seal's fur using hair dye. So we take, $6 hair dye from like CVS or Rite Aid or the grocery store, and then we draw it on a little wooden stamper, and we carefully stamp the seals when they're asleep. And that allows us to see much bigger numbers on the side of the seals and keep track of individual seals much easier. The problem, of course, as you might have guessed, is that they shed their fur every single year. And that means every single year we have to add a new dye mark to the sides of the seals. So this group that I'm showing you guys is a lot of what we call subadult males. So a lot of 5-year-olds, 6-year-olds, 7-year-olds. When they get to be about 10 years old, they start to become alpha males. And during the breeding season, they can actually hold harems, which are basically groups of females that they can mate with. So there's this whole cycle where the seals come to the beach for the molt, then they leave to go to sea, and then they come back for the breeding season, and then they leave to go to sea again. So they have 2 migrations per year. One of our really big research questions is where the seals go when they're at sea. Because you can see right now, I can see all the individual seals. I can tell if they're male or female, get a lot of information about when they got here. But what I don't know is where they were during their migrations. I don't know where they were swimming to, how deep they were diving. I don't know anything about how many fish they caught. And so what we do for a subset of the seals is we actually attach really small devices. Imagine your cell phone, but even smaller. And we glue those devices to the seals. The devices don't impact the seals at all. They cause no harm, doesn't bother the seals at all. And then the seals take those devices out to sea with them. And those devices measure everything from where they are to how deep they're diving to what they're eating. Sometimes we put video cameras on those tags. Sometimes we put accelerometers. So if you guys have heard of like Fitbits or smartwatches where it counts steps every day, that's basically what we have for the seals, except instead of the steps being true steps, it's actually just how many fish they ate per day. So that's sort of the basics of what we're interested in learning about the seals.
Okay, so that is part of a larger video that Roxanne made for us while she was out on the beach with the elephant seals. But that was a nice little summary of the seals and what she's studying, why it's important, and how she studies them. So if there are a couple elephant seal questions, I can probably answer a couple of them quickly after having spent some time with Roxanne. And then we're going to wrap up with our curiosities of the week. So while I wait to see if a question or two comes in about elephant seals, I am going to talk about last week's curiosity. So I happen to have it right here with me. It's this nice piece of green mineral. It's very smooth. I gave you a clue that it was not man-made. So nobody would think that was maybe like a piece of glass or something. It's natural. I think I told you it was from Mexico. Yeah, I think that was the clues that I gave you, that it wasn't man-made. It's from Mexico. It's very smooth. We had some really good guesses, a few different kinds of minerals, a few different kinds of gems. Jade, emerald were a few of the guesses that came in. But this is actually a piece of calcite. So this is a piece of green calcite from Mexico. So it is a mineral. It's a nice one. It's very smooth, very pale, where something like an emerald or something like jade has kind of more of a richer green color. This is a really, really pale green color, this piece of calcite. So this was a piece of calcite. We had some good guesses, but we stumped our groups this week with this piece of green calcite. Let's take a look at our brand new curiosity. Then I see a couple questions here about the elephant seals. So we will jump into those questions very, very shortly. This is our curiosity for this week. This is a little bit of an easier one, I think. I think if you do a little bit of research online, you'll be able to figure out what this is. This is, well, I'll give you a clue. It's not a rock. It's not a stone. It is a fossil. Okay, so we'll take a little bit of a look at this fossil here. This came from, well, what was once an ocean, obviously not an ocean anymore. And then something kind of special happened to this fossil. I'm going to open it up so you can get a nice view inside. So look at that. It's very shiny inside, very smooth. Kind of see some chambers inside as well. And then it fits back together like that. So that is our curiosity for this week. You have a week to have a little think about it, do a little bit of research, and send your best guesses in. to classroom@darwin200.com. We'll put that link up there for classrooms. So we'll open up one more time so you get that really nice view. It's shiny, it's smooth inside. Not all fossils are like this. This one went through a special process. We'll talk about it next week. But what do you think this is a fossil of? And maybe bonus points, because if we have several right answers, it might come down to bonus points. What do we call it when it kind of takes on this really smooth, glassy appearance inside? So there we go. That is our curiosity. Let's wrap up with a couple quick questions here from the chat. There we go. We'll get that open there. Okay. Why do they throw the sand? Will, that's a really, really good question. In fact, another student asked Roxanne that question, and she had to be really honest and say, we don't know. So there's some theories about why they do that. One might be that they're doing it to kind of cover their bodies, protect them from the sun a little bit. So maybe by throwing that sand on, it helps protect them a bit from the sun. Another theory is that maybe bugs really bother them, and if they throw the sand on, it scares the bugs away. It protects their skin a little bit from maybe some of the biting bugs. So that's a really good question. It's a question that researchers are still thinking about. They can definitely see that they throw that sand on quite regularly. So is it for an important reason? Sunscreen, insect protection, or maybe they just do it because they just like the way it feels. Maybe it cools them down a little bit because it is kind of that wet, cool sand. Okay, we have questions. Lucas wants to know how big an elephant seal can get. So elephant seals can get really big. Males can be 16 feet long and weigh over 5,000 pounds. Can you imagine that? A male elephant seal over 16 feet and over 5,000 pounds. Females are a lot smaller, but still 10 feet and about 1,300 pounds. So that is still pretty big. But compared to a male that can be over 5,000 pounds, that's pretty impressive. Okay, another question here in the chat about holding their breath. How long can they be underwater? Pippa would like to know that. And they can dive for about 2 hours. So imagine that, most people can't last longer than a minute. People who train, like free divers, can last up to like 9 minutes. Some of the biggest records. They can be underwater, the elephant seals, for about 2 hours and dive to really great depths. Roxanne mentioned like 3,000 feet, like the height of a 30-story building, which is pretty impressive. Okay, let's see. I think there might be one more here in the chat. We got the underwater. How big? Lifespan. Scarlett wants to know lifespan. So on average, about 9 years. It's not easy being an elephant seal. You got to find food. There's less food to find now in the ocean. You're diving to really deep depths. And then things like sharks, orcas, think that you're pretty tasty too. So about 9 years is kind of typical. So the ones in the north, they can be found in the north, like further north. They live a little shorter, more like 9 years. And then in the south, the southern elephant seals can be a little bit longer, sometimes about 20 years. But the male always kind of has a shorter lifespan because they spend so much time fighting, trying to control a beach with the females. So the males are often getting hurt in these big battles. Imagine two things 16 feet long, 5,000 pounds, slamming into each other over and over and over again. How do they move on sand? Well, Sasha had that question. The answer is not great. We saw them kind of almost like a worm. They kind of undulate, wiggle their bodies. So they have their back fins, which aren't too helpful. It kind of lets them push off a little bit. And then they have their front fins, which are a little bit bigger, maybe a little bit stronger, that help them kind of push themselves forward. And they kind of use their whole body almost like a worm, like they're doing the worm across the beach. Again, when you're not in the water, you're pretty heavy, moving 1,000 pounds, 2,000 pounds, 5,000 pounds. But in the water, it's a different story. They're amazing swimmers. They're fast. They can dive to those deep depths. They can hold their breath. But once they got on land, it's a totally different story. It's a lot harder. It's not their natural environment, so it's not as easy for them to move around. Okay, I think that's where we'll leave it for today. I want to give a shout out to our classrooms. Thank you so much for joining in, sending in some great questions. And yeah, I hope you enjoyed a little bit of that research. We talked a little bit about invasive species and how they're trying to control them using native species like the falcons. We had Roxanne on the beach for us with the elephant seals. And now you have your new curiosity to check out and see if you can figure out what this is over the course of the week. We're going to end off with a shout out to our sponsors, supporters, and partners, without whom we wouldn't be doing sailing around the world, hosting live events for classrooms, having researchers on board, sending Darwin leaders into the field with conservation projects. Yeah, we owe them a huge thanks and a huge debt of gratitude. We will see you next week at the same time. We will have another fun event for you. But for now, have a great rest of the week, and we'll see you soon. Thanks, everyone.